I'm crossing my fingers that the sound's working. I think those mics are on and this mic's on, so I'm capturing sound and it's on the recording. That's it. That's the end of it. We'll start off thanking Vivid for the space and the pizza and letting us come here today, and for being voluntold by your manager to come. My goodness, it's November.
Yeah.
That's what I meant. The other thing. It's October. It's fall break for some people, I guess. Not me. Announcements. We'll start with Slack. This is your first time at the meetup. We do have an online Slack community. We have a very quiet data engineering channel in that community because we're all too busy working to be distracted by Slack. You can join our Slack. Just go to forgeutah.tech. That's our website. There's a button that says join Slack. There's a job board on there if you're looking for jobs. There's fun channels where we talk about AI and data engineering. And I just found out there was a memes channel that some people really enjoy and other people think is just spam. I didn't even know, and I'm a Slack admin. But anything tech related, we have every channel for like almost every single interest that can be there. We also have several other meetups. Next week there is a MLOps meetup where they'll be talking about data scraping and analytics on scraped housing market data. I think that's what it was. And also next week is my annual Go conference. If anybody likes Go, the programming language, my conference is next week. They got me to speak about my AI bot, and I'm going to make everybody break it live in the demo. Yes, this is the one I code on my phone. Exactly. No, I'm Pete. The bot's Pedro. It's a pun. Yeah. I don't think I have any other now. Oh, yes. Is anybody hiring? I know Jake is hiring. Okay, go ahead, Jake. You can announce yours, and then we'll let Bill announce his.
Sure. So I'm Jake. I'm a data architect at Autodesk. We're still working on the job rec and things like that, but we're looking for a senior principal engineer. We've got a few dozen data engineers working on our enterprise data platform. We need somebody really at that senior principal level to help guide and help people navigate and help us build that up. So, details to follow, but if you're interested in like an early conversation, talk to me. What we can do.
Bill.
So I work for Schema and Draper. We had 25 openings. I haven't checked in a little bit. I know that we had filled our two senior data engineer positions, but one of them he could no longer accept due to a father's failing health. So we're looking for that one again. And if someone is experienced in AWS, Python, and Snowflake, that will definitely help you go far. There were some data scientist positions, software engineer, and probably some more too, but those are the ones I noticed.
Anybody else hiring?
I posted about this on
I've seen it.
Yeah.
Might have been a couple weeks ago.
Yeah.
That's why we like history. Cool. So if you're looking for jobs, Jake and Bill are currently your points of contact. Anybody else? Cool. I do not know how I got Mary to speak twice in 1 year. She was pregnant last time she spoke.
I know.
And so now she's here with like a brand new, she just left her baby at home getting some, oh, this is probably cool for you. This is relaxing. I asked for somebody to speak about star schema because I have spent the past 3 weeks doing dimensional modeling with the help of AI because I have no idea what I'm doing. And so I need to be educated. She volunteered. So I'll be listening attentively. Everybody, let's give Mary a round of applause.
Thank you. Hello, is this on? Oh, it is. Okay. Let me know if I don't know. Is that good? Or is that okay still? Okay. Making sure y'all can hear me. Hi, I'm Mary Welsh. I am currently a data engineer at Adobe. And I've been in the data world for 13 years or so. I was a DBA, I was a data analyst, and was a data engineer. I've done a little bit of everything. But I've done a lot of star schema modeling. That's kind of like my special interest and my area of focus. It's okay. Oops. I'm gonna like move this over so I can see it. Okay. All right. Yeah. So that's a little bit about me, and we're going to talk about star schemas. And yeah, we're going to get into that. So a little bit of background before we start. In the database world, there's two main kind of usage for databases. We've got their OLTP environment and your OLAP environment. Your OLTP environment is going to be more for your transactional databases. So lots of data movement, and it's very small data movement, but it's very frequent. You're going to have lots of transactions. It's going to be, it's designed to quickly process tons of little tiny transactions. And so it's very different than OLAP. And OLAP is the world of analytics. And that is where you're going to have a lot more of the historical data. Your data is not going to be moving nearly as quickly. It's going to probably just sit in a warehouse, which we'll talk a little bit about. And that's where you can analyze historical data for trends or, any forecasting, stuff like that. So analysis world. And obviously these two paradigms have very different architectural philosophies. And for this is just an image of like the difference between OLTP and OLAP, because a lot of the times OLAP will come from an OLTP source. So the middle step is your ETL, and that will give you what you need in your final form. So a little bit of background on normalization. Now, normalization is what we talk about with how the data is structured, basically. So with these two different paradigms in your database, you're going to have very different normalization techniques. And so, for example, this in the OLTP environment, you're going to have third normal form very regularly. That's pretty standard database practice for OLTP environments. That is going to be more optimized for these small scale transactions and for moving data quickly. And it's going to condense your data so that it's not, it doesn't explode in size. So it makes these these little processing transactions much quicker. And here's an example of a third normal form that we commonly see in these environments. As you can see, we have a book table and a genre table. So this is all of the books and all of the genres of the books. And this genre ID is going to be a foreign key to this genre table. So this book ID number 1 is genre ID 1, which is a gardening genre. So that's kind of an example of a third normal form. You're going to see that a lot in OLTP environments. Now, the difference between these two environments is the OLAP way of things is going to be much more denormalized. You're not going to use third normal form very commonly, if at all. You might in some very weird use cases, but it's not very, very common. So the reason is because it's going to be prioritizing the rapid query performance and data ingestion. So OLTP is more for like putting data in the database, and OLAP is more for getting data out of the database. So different uses of the database. So now we got to kind of talk about where star schemas kind of show up in the data modeling approaches. Now, these are the three that you're going to see where the star schemas show up the most. Kimball is where the most traditional star schemas are going to be found. Inman does have a few, and Data Vault has what looks like a star schema, but it's kind of different. It's more focused on like historical data. It's going to be it uses a hub and spoke schema. So this centralized table is a hub, and the spokes all contain like historical metadata. So it's a little bit different than your traditional star schemas. But these are just some differences between these approaches. And we're going to dig more into Kimball because that is like the most traditional, where you're going to find your traditional star schema methodology. So We're going to go into asking, like, why would you use Kimball? Well, this is a very common question, and a lot of people seem to think that star schemas in general are dated. And yes, they're very old. They've been around forever, and but there is a reason that they are still around. They're still very relevant, and they're still absolutely useful. And there are several reasons why we would choose the Kimball methodology that uses star schemas. One, the most important, I think, is the user-centric and intuitive design. I think it's, oh, yes.
I can't read that from over there. Can we get this mirrored over to this TV?
Turn the TV on, sorry.
Oh, yes. Sorry. Pause.
I don't even know who that TV is. It has a
Yes, sorry.
Titanic.
Yes, thank you. Thank you. Yeah, so it's just really easily digestible by both the users and developers. Let's see, is it gonna turn on? Technical difficulties.
Nope, I wasn't even pressing.
Oh, there we go. It's on. There we go. Okay, so we've got the most important, I think, is the user-centric and intuitive design. It's very easy for humans to understand it, as well as on both sides of the fence, for the non-technical and the technical people. It is much better for performance in these OLAP environments. It actually performs really well in columnar-oriented databases as well. It's a data modeling technique where we have a centralized fact table and surrounding dimension tables, also called DIMs. And then the joins here, these they're foreign keys. We're going to have a one-to-many relationship, and that will make it look like a star, and that's why it's called a star schema. And so you're going to have these relationships. Many facts can have one of these dimensions, and it just keeps things much more simpler that way. So some of the common characteristics we have, we talked about having a fact table and a dimension table. So fact tables, that's where you're going to have your quantitative data. That's where you can ask questions such as how much and when did something happen. So we'll go over this a little bit more in the future too. And then the dimension tables are going to be descriptive attributes. So the who and the what of all of these data pieces. And then we've got structural characteristics. We kind of touched on how it's denormalized, and we'll talk about that a little bit more. It's definitely not going to be third normal form, and you're going to see a lot of what looks like duplicate data, but it makes sense in this paradigm. And we kind of mentioned this again before. It's a simple single level relationships. So it's non-hierarchical, and all of the dimensions connect directly to the fact tables. So let's go over what a dimension is. So there are definitely the most common types of dimensions. We've kind of talked about how a dimension is like the attributes, right? So the most common you're going to see a date dimension in every single data warehouse you will run into. It's just best practice. This
Say that. Well, it deleted my date table.
You should. It is best practice.
Multiple times.
Oh no.
No.
Don't do that.
Eat it tomorrow morning.
The reason for this is because dates are such a fundamental aspect of data, because that's the when of things happening. And when you ask these questions about when something happened, when you have a date dimension, you can then slice and dice and roll into the data and get every single attribute about that particular date, and to see exactly what's going on at that particular date. And I'll show you examples of all of these in a second. A junk dimension, this is going to be a Cartesian product of every single column in this table. And the reason for that is because you want it to contain every possible combination of these attributes, because you never know if your fact is going to have a certain set of attributes, and you want to account for every possibility there. And then the most famous one is the slowly changing dimension. This one is where you're going to have your historical data baked into the structure of your table. And this is where it can track how the data changes over time. And this is very often done by date grain. And so you can kind of tell how the data is changing by date every single day. It's really, really powerful and useful. So slowly changing dimensions, there's actually different levels of slowly changing dimensions as well. So these are the most common types of SCDs. It actually goes up to like type 6, 7, but I've never seen that in my life, and it's kind of ridiculous at that point. So the type 0 is just retaining original. So basically a static table, nothing happens. Type 1 is where you're just overwriting the data and you're not tracking anything historically. And then type 2 is where it gets interesting. And this is where the most common slowly changing dimension you're going to see is going to look like. So this is where we have a new row created, and it will give the new information, and then it will have a valid from and valid to date to kind of time when you have these records and when they were valid. So let's go over some of these examples. So here's an example, dim date. And as you can see, the table is very, very, very wide, and it could just keep going. You can have as many columns as you want within, reason. You might get some performance degradation with certain RDBMSs, but in general, dimensions are okay to be very wide. What you want to look out for is for them having too many rows. So dimensions shouldn't have too many rows. In this dimension, this dim date, it's very common to have the date from like the start of time, or 1900 to a date far in the future, like 3000 or something. But you can kind of change it to whatever your needs are. Basically, you just have to account for any of the days that are going to be in your data warehouse so that you can tie to one of these. Now, as you notice, we're looking at all of the different attributes of a particular date. You have a date key, that's going to be your primary key. And that is very typically speaking, just an integer representation of your date. And then basically anything you can possibly think about that date. So whether it's a day, like whether it's a Tuesday, whether it's a week, like what's the week number in the year, what's the begin date, and you can have, if it's what fiscal month it's in, you can have whether it's a holiday, whether it's a company holiday, anything you want. And you can have any of your business logic as well, any of the business needs that you want to care about in this table. So that is very fundamental, should be in every data warehouse because that's a very important thing to have. You can also have a dim time dimension. If you're looking at specific times and hours, you can have it by hourly. That's kind of getting a little bit more fine-grained, but it is an option you can have if that's what you're looking for. So here's an example of a jump dimension. Now, this, like we talked about before, it is a Cartesian join of all of the possible values in these columns. So this column, it can be either cash, Visa, or MasterCard. This column, it can be cash or credit. See, so it's just going to be basically a Cartesian join so that you can have every possible combination of that. And then you're also going to have a surrogate key here. Normally, this is a surrogate key. So surrogate keys can be, basically it's like a unique identifier for your rows. I kind of like to think of them as if you're in an Excel spreadsheet, it's like saying, okay, it's row number this. So that can tell you exactly which record you're talking about. That's all a surrogate key really is. So it means something to the database and how you join and things, but it doesn't really mean anything to end users. So that's kind of what a surrogate key is. Also, this is one way of doing it. You can also there's another kind of methodology that people use, and that's using hash values, and that can come in handy for slowly changing dimensions as well. So yes.
There should be a dimension for each one of these 4 columns, right?
No. So this is all everything that has to do with an order is what this dimension is. So what is the order payment type description? It's any one of these, right?
Shouldn't there be a dimension table for payment type, another one for order?
No, so that's more like normalizing things. So this is kind of where the denormalized structure comes into play. And that's why you see duplicate data here, because this is not their normal form. Okay, does that make sense?
Yeah, I just figured there would be a dimension table holding the valid values for each one of these 4. And this is just a combination of them just so you can save space on the fact.
Exactly. So it's you kind of group together like related entities. So anything about an order, what is an order? Like what is the order type? What is the payment type group? And what is the, what is this about an order? So anything that kind of relates to an order would go into a dim order table. Yeah.
In a transactional database, it's not duplicated data, right? What table they don't have all the
Yes.
the commission credit indicator.
Yeah.
Why is it in Kimball form we're okay with duplicate data? What's the purpose for that?
Great question. So the reasoning is because it doesn't really matter in this paradigm. You're not going to be joining so many things. It reduces the number of joins that you have. So if you wanted to get all of the information about an order, it's just going to take one join as opposed to joining to anything here and then anything here and then anything here. Does that make sense?
We're trying to reduce the number of joins. And if
It's performance based. It's very expensive in databases, and that's kind of one of the reasons that the one big table philosophy is kind of coming out as being like a competing architectural practice.
I did read about that.
But yeah, there's that's a whole kind of other can of worms that comes with its all own pros and cons, and ultimately that architectural ideology really only fits for like specific use cases. It's not as like broadly usable, whereas this is definitely more for like data analytics and reporting. One big table has been more useful for like AI consumption because it's just easier for AI bots to get to data.
Miss Harris, we're trying to get results back as fast as possible.
Yeah.
To the user as opposed to saving space.
Yes, exactly. That's exactly it. Mhm.
Have you ever tried to run a heavy report on a transactional database? It's like 50 joins and the SQL is,
Yeah, it gets messy.
takes 5-6 hours to run.
Have you done this recently?
Not this exact thing, but yeah, it gets really messy with transactional databases, and this is why we're kind of going this way, because we're trying to reduce the number of joins that can be really complex and complicated. And also these systems are more they're more catering toward ingesting, like selecting the data as opposed to inserting the data like OLTP. So that's kind of where it's being optimized, is the data retrieval. Yes.
So coming back to Bill's question, I can see an argument for having a payment type dim. What's your philosophy on when to put it all into a junk dimension versus when to
That's a good question too. So in this case, we are seeing that there are only like a few, like the cardinality is low. So we're only seeing like 3 options for this column. We're only seeing like 2 or so options for this column, right? So the cardinality is pretty low, and therefore it makes a Cartesian join like not that big of a deal. If it were like every single record is different for billions of rows, that would be just stupid. Like you would not want to Cartesian join that with anything, because that would just explode and be super unperformant. So if you have a low number of values, it's very useful to that's usually a signal that needs to either be in a junk dimension or a degenerate dimension. We'll kind of touch on that later. Yes.
It sounds like you're basically kind of, to a degree, saying take any kind of table that would be like a lookup table and just push them.
Yeah. Essentially what it is. It's just kind of a lookup table with every possible combination of what an order could be. And it's just to eliminate the joins of like, I want to join to this, what that could be a table. In third normal form, yes, that would be its own table because it only has 3 values, and that would be a table of 3, super small tables, but you're getting lots of little tables, and then the joins just get out of hand. So just different ways of thinking about it. Yeah. Anything else? Good.
Wait, I have a question.
Yes.
But I might answer it later.
Okay.
So AI told me about this thing called a bridge dimension, which was supposed to essentially
Yeah.
one dimension to
Another.
dimension.
Mhm.
Are you gonna talk about that? Did I
A little bit. Yeah.
like Mariah's so far?
No. That is a thing. It's not, I wouldn't say it's very common to run into those. And I'm not sure it's it's debatable over whether that would be best practice, just because we get into we'll get into like Snowflake schemas in a bit, and that's not Snowflake the database. Snowflake the database is great. Snowflaking in Kimball world is usually a no-no. So we'll get to that though. So next is our very famous type 2 slowly changing dimension. This is how they work. So this would be our original table here, right? So we've got our product name, product ID, and product description. So let's say someone goes in and I want to change this product description to say this instead. So what that would look like in a slowly changing dimension, we have our surrogate key here, and then we've got the source product ID here. And then what we have is for this 010, this is the original record right here, right? So it says this is what it used to be, 10-inch glued box. And this is like, this could be the start of time, this could be null. It depends, it just kind of depends on how you want to do it. There's preferences. It doesn't really make a huge difference. But sometime that was just beginning of time, basically. Once this changes, this end date, these are often called valid to and valid from to, by the way. That's just what they called it. It's kind of sixes. So this gets updated to today's date. I know that's very old, but so that's today's date. And that means that this record was valid from the beginning of time till today's date, right? And then we add a new record for the new changed value here. And there's the new values. And then we have a valid from date as today's date. And then the end date is going to be either null or the end of time. So that when you query this, you can say, okay, I want it for this date. Then you can look at, okay, well, where does that date fall in? And then you can see what that value was at that date. Yes?
Should the old end date and the new start date be the same date, or should they be yesterday and today?
So it should be the same. These two should always match.
Okay.
And then this can either be null or the beginning of time. This is more commonly a null. I've seen that more commonly as a null, but you can also do that.
You'll get two results.
Oh, no, it's exclusive. So this is, it's just until this date. For this day, it will be between the two dates. So like a SQL statement would be like between, and that's usually exclusive of the last date. So if you were to query for May 12th, I believe you would get this one instead. So, and oftentimes these are timestamps as well, because if your data is changing really fast, you want to make sure that you don't have, oh, this changed on the same day over and over and over again on the same day. You want to make sure they're timestamps. And a lot of do that for you. DBT has an awesome SCD type 2 functionality. They call them snapshots though, which is unfortunate because that means something totally different in database land. But they are effectively slowly changing dimension type 2s. Yes.
In the theoretical situation where we're timestamps instead, would those timestamps match as well?
Yes. Yeah. So when usually in the back end with whatever tool you're using to implement a slowly changing dimension type 2, it'll just update it all at the same time.
Yeah.
So yeah. Anything else? It's very, very awesome technology. I actually just implemented a slowly changing dimension type 2 in my current work, and it shrunk the data, like the tables, these original tables. It went from it shrunk them down from their original size by like 98.5%. So it's insanely powerful for shrinking the data down, consolidating it, giving you historical data for every single date. But keep in mind that if your data changes a lot, this table is going to be a lot bigger. So
You don't want a rapidly changing, slowly changing dimension?
yeah, that's why it's called slowly changing dimension, right? You can have rapidly slowly changing dimensions, but it might just not be very performant. So
If your data is changing a lot,
Mhm.
what might you want to do instead of that?
that would probably be more of you need to readjust and reassess whether the data that you're ingesting is actually dimensional or if it's actually should have been a fact instead. Because fact tables are where you're going to get lots and lots of data. And we're going to talk about them next. So fact tables, this is your main, their main the center of the star, it's going to have most of the time you'll see some sort of aggregate function or some sort of value where you can aggregate it. So like if it's a dollar amount or like number of sales or something like that. So you can like quickly aggregate, okay, what's the average, sum, mean, median, mode, whatever. So that's what facts generally are. There are three main types of facts. Transactional is going to be the most common that you see, and that's where you have one row per event. And we'll look at some of the examples of this in a second. The next one is the periodic snapshot. This one just captures the status of a process at regular intervals. So every time it's just going to update at regular intervals. So you're going to like just kind of do a periodic update. Okay, now my sales inventory is this much. At 10 o'clock, it's this much. At 11 o'clock, it's this much. So it's just regular intervals of updating these values. And then finally, we've got the accumulating snapshot. And this is going to show the progressions of a single process over time. And so it'll keep updating those records as a process moves from step to step. So let's look at some examples. So transactional, this is like kind of the main fact table that you'll see. The grain we talked about, granularity, by the way, grain means like what your record means, what a single row means. So you can't have one row that is a date and then one row that is a time, because that doesn't make sense in this time scheme, because you need to have it all one grain, every single table. So these tables will tend to be unpredictably and sparsely populated. So these are going to be really, really big tables. These are going to get super, super big, billions and trillions of rows. Now, important thing about fact tables, they should not be very wide because of this. If they're wide, you're going to run into performance issues again. And there's a chance that you're pulling in dimensional data when you probably shouldn't. So for this example, this is kind of just a schema snapshot of what we have. So we can have surrogate keys in fact tables. You can get away without them. It's kind of up to you how you want to structure it. But this is where you're going to see foreign keys to all of your dimensions, and that's where the star schema comes from. So you're always going to have your foreign keys. This is going to be what we call a degenerate dimension. A degenerate dimension is basically just, this is a number here, like it's a transaction number, but we don't like sum transaction numbers. That doesn't make sense. So it's kind of a dimensional attribute, but it doesn't belong in its own dimension, because that would just be a one column dimension, and that's silly. And also it would be very long, like a fact. So it's just easier to put it in here as kind of a primary key. And then we just have all of these values that we can aggregate by. So quantity, prices, amounts, etc. And this is really awesome in columnar-oriented databases because they're able to aggregate super fast. They're built for this, so works really well. Periodic snapshot. This is where the grain is a period of time and it's not an individual transaction. Like I said before, it's at every hour or every day. We're just taking like, what's the data at this point? What's the data at this point? And it's very regular intervals. So this is just quantity on hand, and we're just looking at that in regular intervals. So super simple. And even if no activity takes place, a row is still inserted with just zeros or nulls. And then we've got the accumulating snapshot. This one is the grain is the order or the order line. So an individual process. In this example, it's an order. It summarizes the measurement events occurring at predictable steps. And yeah, so as it goes, the fact table keeps getting updated and revised. So here we've got all of our foreign keys. And yeah, some of them have lots of foreign keys because there's lots of dimensions. We've got some degenerate dimensions. And then this is where the process is outlined for this accumulating snapshot. So first, it starts out with the order quantity, and then this is how many released to manufacturing quantity. And then this is how many passed inspection. This is how many failed inspection. So every step of the interval or every step of the process has a column, and it gets updated every step of the way. Does that make sense? So things are moving along, and as an order is processed, that will get updated. And this is how many passed, and this is how many failed. And So it just keeps getting updated as process continues on.
And you said those were always quantifiable that you would put in effect, correct? Like you said,
Yes, yes,
when you, what was the factor? Like,
Yeah.
quanti-
it's quantified. See how they're all quantities and amounts?
and it was
Yes, yes. So they're all like amounts, quantities, those kinds of things. There is such a thing as a factless fact too, and that's one that doesn't have a quantifiable amount in it. It basically just keeps track of event time period. So it's kind of just all about the time. So if something happened at this time, or if you need to like kind of consolidate two different processes that have different timing events just to make sure that you keep track of their timing, basically. That's kind of more of a factless fact.
And really quick,
Mhm.
the difference between a dimension and a primary key is just
Mhm.
we're in a normalized context versus not. Yeah.
There's kind of an overlap in them because I really think that these could be considered PKs, but they're not strictly in the sense of a primary key because by definition, a primary key is always unique. And in this case, you could have, an order line number that's the same or something. It could not be unique in a lot of these.
so something you'd optimize for querying name on.
So
Yeah.
those dimensions could you could combine them into a surrogate key that could potentially.
Yes. And the surrogate key is more commonly and more advisably used as a primary key because that is always unique by definition, because you are defining it either as a random integer or as a hash value of all of the records in there. So,
So the foreign keys that are dates, those are also getting updated, right?
yes. Oh no. So this is when the original order happened. And then this is, see how these are a lot of different dates here? So these are all of the events for all of the different dates. So this date will get pushed first. And then as the process continues, then this is when the backlog happened. So that'll update. And then this is when the release date happened. And so it'll just keep updating the columns as the process continues.
Because a date dimension exists.
Yes, they do.
Speaking out loud.
Yes, yes, they all tie to a date dimension. Yes. And another key aspect about dimensions that's commonly, it can be overlooked sometimes. A lot of times people will put just a row of just all nulls, just in case it is not applicable. And that is to preserve the join integrity. So when you want to join things and you do an inner join, that's going to remove records, right? So when you have a completely null row, even if you inner join, you will not lose records. Does that make sense? Yeah. So a lot of times you'll have a dimension with the first row of just all nulls just to account for doing inner joins so you don't lose records.
Never thought of that.
Yeah.
Just dealt with losing records today and I should have had enough.
Yeah. So I have seen some people not do that, but it is a good idea to do if you want to avoid potentially losing records if you accidentally do an inner join. Yeah.
Question on the dates. Is there a reason why you would want a date key versus like?
Yeah, good question. So date keys allow you to join to our previous dim date, right? So we saw our dim date right here. And when you join to this, then you can query the overall star schema and say, I want to look at all orders that happened on a Monday, or I want all orders that happened on a bank holiday. That'll instantly give you that information. Whereas if you just had the date, you wouldn't have that information. You would actually have to go back and join to this anyway. So it's just good to have that there so that you can slice and dice any date into this date dimension.
It's the common SQL tuning technique. If you're having problems with date functions, break it into a date dim because your date functions are going to chew.
Yeah, and this is another great example of what to do with like date functions. Like any way you can break up a date is good to have in here. So see how we have like, this is the day of the week. This is the full date format. Any kind of date formatting or any kind of date attributes, put in this table, and then you can just reference it whenever you need. Yeah. Yeah.
Going along with that as well, like my favorite go-to example is when is Easter? I don't know.
Yeah. It always changes, right?
Do you want to calculate that on the fly or do you
Mhm.
load it once?
Yeah.
Easter for the next 1,000 years.
Mhm. Yeah, exactly. It makes it super easy. I think you were first, John.
The other reason you had the keys is because in the other example that Mary had up, they were all foreign keys referring to this table. They're also called a role-playing dimension. That's what, like, you can, because it role plays for like multiple dates, if that makes
Yeah, yeah.
the idea.
Just an anecdote about dates from some of my work in campaign political data. Dates started, or our weeks, they started on Friday and they were countdown weeks until an election.
Oh, that's annoying.
Had to make kind of date like this.
Yeah, and it helps so much if you have weird dates. Like at Adobe, we have our fiscal year and like the what is mostly accepted, they do fiscal years completely differently. So that like it's just they never line up. And so this just makes it easier to be like, oh, on this actual date, what's the fiscal date? You know, like what is that? It just makes it super easy because it's all in one place. Yeah. Good. Right. And then we got at the end, we're talking about snowflaking because a lot of people will reference this, but yeah, it kind of is. So it can be a bridge dimension because I think bridge is more in a sense of there's a fact over here that also will go to these tables. And so I think that's how yeah. So it's a little bit, yeah, I wouldn't say that that's ideal. You can do it,
Yeah.
but yeah.
If the bridge is just to break a many dimension.
Yeah. Yes.
Totally get.
Yeah.
I'm aware that I'm not doing this. Learn about it.
Yeah, it's great. So a snowflake schema is when your dimensions start to break out into further more dimensions, and that's more normalizing. And a lot of people will kind of fall into that trap because they're used to the OLTP third normal form, right? Like we kind of talked about, because we have a dim store, but then why would we put a dim store city in its own dimension when it could just go in dim store, right? You're getting a little too fine grained. And the reason it's mostly looked down upon in Kimball methodology is because it just increases complexity and joins, like right how we talked about how we want to minimize the number of joins because we want denormalized data. So this is something you can do. However, it's looked down upon in Kimball land. So yeah, it's just, and it just becomes difficult for business users to understand. It just gets a little tricky and a little hairy. Yeah, so that is a Snowflake schema, not to be confused with Snowflake, the database, which is an awesome tool. So those are kind of like the main points of star schemas. And basically all of this information can be found on the Data Warehouse Toolkit. It's like the Bible for all things star schemas. It is the most beautiful thing. I love it so much. It's just really, really cool. And it gives lots of these examples. Like almost all of my examples came from that book.
Nice to them.
Yeah.
I did read the book. I just looked at
It's great. It has lots of different use cases like inventories and pharmacy and accounting and all sorts of things. So you can look through and see like, how would I model this kind of data? And so it's just got you covered. It's super cool. So great book. I highly recommend it. And there's also lots of other sources online for, how to do this stuff, but still very cool.
Ralph Kimball, something or another. Like you search Kimball, that comes up first. Then there's a website where it's just like everything else Kimball.
Yes, they have their own website and it's super awesome. You can like reference a bunch of stuff and it's, you can find all of basically all the materials in the book is online. It's like the Kimball group. The Kimball group. Mm-hmm. And they have like all sorts of cool stuff there. Yeah.
Go ahead, Jake.
Yeah.
Question's not real. Go.
I'm gonna ask you this question anyways. So I'm a Kimball believer through and through. I think it's great. Data Warehouse Toolkit 3rd edition, I think came out 2011, 2013. Margie and Ralph have since retired, and I don't see a lot of people out there. I don't see a very authoritative source pushing for this.
Yeah.
Know of anybody that does that, or
Me. I am.
Some
I will hunt you down. No. Yeah.
An influencer, but I don't
Yeah.
see somebody with that,
Mhm.
that developer relations
Mhm.
for
Yeah. And I think for that reason too, I think that it gets a lot of like PR that's like, oh, this is so old and no one uses it. It's irrelevant. And it's like, yeah, it's old, but it's still relevant because it's worked for so long and it has so many advantages in specifically the reporting and analytics side of things. And then there's further architectural philosophies that go off of like the actual warehousing thing where like you have data marts and OLAP cubes that no one uses anymore and like a ton of other stuff that you can build along with this to complement it. But I still think it's absolutely relevant and very useful.
You get a copy of your PowerPoint?
Yeah. I'll post it in the channel and Slack.
It's also
Yeah.
YouTube. We're live streaming it. So,
Mhm.
anybody can go rewatch this.
Yes.
I'm just gonna say a good Substack, and he actually used to come here as Joe Reese. I mean, he's really
Too
well
busy.
known.
He's in Europe right now.
His Substack is available, and Joe is actually really good friends with Bill Inman, but he's
No way.
kind of out of the spotlight. But
Yeah.
he does a lot on data modeling. The other company, if you're interested in stuff, and again, not to slub for a company, SQL DBM spends a lot of time talking SQL modeling.
product.
If you're on Snowflake,
SQL DBM.
their developer advocate just released a book called Data Modeling on Snowflake. I reviewed and it was awesome.
Oh, cool. Yeah, I'm gonna have to look that up. What can you say that name again? It was SQL
DBM.
DBM, and the book name was
It's data modeling with Snowflake.
Data Modeling with Snowflake.
Edition 2 came out like
Is it an O'Reilly book?
a month ago.
Is that the
No, it's actually he's published it.
Is that the one Serge wrote?
Yeah, Serge. Yeah, like Serge is another one to follow on Substack.
Nice.
Steve Hoberman is another one of the.
Yeah. Steve's more focused on like he gets into with fifth normal form and like he focused on that OLTP modeling much more than
And data warehouse.
OLAP modeling.
I just have a quick question. I know that star schema is better than a Snowflake, but in what case scenarios?
Yeah.
A Snowflake schema outweigh the benefits of doing a star schema?
Oh, don't make me answer it. No.
These days.
Oh yeah.
Being-
Yeah, Bridget.
Doing it wrong. I do think, to be fair, size matters.
Mm.
So,
Yes.
smaller data warehouses.
Yeah.
Are going to not hurt by having the more joins.
It's true.
And you're not going to have as much time for modeling. And so
That's
you're
true.
going to be able to really set up that kind of Snowflake situation.
Yeah.
And not feel the cost. And you're not also going to invest the time into the modeling to be able to get your analytics out.
Mhm.
So that's when I would suggest.
Yeah, absolutely.
Not my use case, because I refuse to do business analytics. That's where I would see that being super. Is you don't have the time to make 30 different facts, but maybe you can make one and you can just have multiple relations to it, or just like it's a quicker. And again, size matters. If
Yes.
not doing 20 billion rows, you're
Then join.
be expensive.
Yep, absolutely true. That is a good point. Yes.
I just have a generic question. So, if I have to translate a business requirement into a modeling and then use them for reporting, like what's the high level effort involved? Like, is it there's a business requirement, and you have to model it, and then you have to build a report out of it? Like, how quick can we do with this task?
It depends on a lot of factors. It depends. Yes, it depends on the business logic and the rules. It depends on what the data looks like in the source. But basically, the steps for developing a star schema are to look at your existing tables and try and find commonalities and where that you can consolidate some of this data. So if you see if you see an order table, then that could be its own fact because orders usually have amounts. If you see like a people or customer table, that's very obviously a dimension because that has attributes about a person. But then you got to make sure that you are aware of not mixing up a fact and a dimension. So there's, keep in mind what a fact is, keep in mind what a dimension is, and don't confuse them, because then you're going to end up with weird performance and just like the business logic just kind of breaks down and stuff like that. So yeah, just keep in mind, like, how do I consolidate this data into like groupings that make sense from a star schema perspective? That makes sense?
Like that question is a whole book on itself.
Yeah. And yeah.
Your brains to see how you
Yeah. Mm-hmm.
take like weeks and weeks to model it versus.
You can sketch out like if you're given like 5-10 tables, you can kind of sketch out like a rough draft of it in 20 minutes or something. But again, it goes back to like what you're dealing with, your data complexity, your business use cases and rules and logic and all that stuff. So it really depends a lot and can vary a lot.
But like, was it 3 months ago or was it a year and 3 months ago? I don't remember.
Late spring?
Yeah, on contextual modeling, and that's like if you can, what's conceptual modeling?
Understanding the conceptual, the logical, and the physical data model.
Essentially, like if you can nail down the business requirements and what the data is, it's going to go a lot faster than if you have to be like, okay, I have this problem, what is, right? And so I think like when you're asking to scope things, I was just explaining this today. There's usually 2 areas of complexity. One is going to be, do I have to get the data, and where do I have to get that data from? That's completely independent source of complexity. If you don't have any data, like that's something you have to discover and scope completely independently. And then the next one's going to be that, great. Now that I have data, what does the data mean? Where does it have value? That's part of the conceptual model. And then like the actual infrastructure of the modeling itself, that's completely separate scoping thing. And so it's like, yeah, that can take anywhere depending on what you're doing. If you're completely greenfield like me, it's like, I want to get this out fast. If I'm taking longer than 2 weeks, it's a problem, but I have no value to maintain. I could throw my warehouse out tomorrow. If you have something established, yeah, it could easily take 1 to 6 months, depending on scope and scale and what you're trying to do. But like it like, I don't know. Sometimes I like to say data products move slow. And that's because you're trying to balance a whole lot of slow moving data with fast moving situations. And it's interesting.
I love the agile methodology because I was involved like 15 years ago in a very large local organization in a project where we did a 6-month waterfall project. And the first day that we showed the dashboard, they were like, I see 6 things wrong with this dashboard. And it was like, they loved it, but they also had a bunch of feedback. So if I can go write a query and like you get your business requirements, you go write a query and you say, does this answer your question right now? I know it's not going to give you the long term, it's not going to give you every day, but like, does this answer your question? And use that agile methodology that programmers talk about, but with data modeling, where you say, hey, I have some flexibility because if I'm using Snowflake or Databricks or any of the other, like I typically have more flexibility than the old way of like literally. And anyway, it's the LDS church. So we actually would spend months reading Kimball's book and like going over and looking at all our conform dimensions and like mapping the entire bus architecture, the data.
That used to work there, and she said the same thing. She said that Margie Ross actually came to visit you guys. I'm so jealous.
Oh, and see too, like, but they spent so much. 6 months, like I came into this project at the last minute and they're like, he looks at the dashboard, he's like, I can't use this. And I just wasted, like I went back and we made it work. But the idea is if you can show them incremental steps, hey, it's so much easier than trying to like, let's go get the product and do it. And
that's kind of where Kimball methodology comes in too, because you're doing the bottom up instead of top down. Where you start with smaller pieces and incrementally go, instead of the Inman process is like design the entire data warehouse and the enterprise, and then you can scale it down to specific. That's another key difference. Okay, yeah.
Can you go back just a couple of slides showing your star schemas?
Which one?
Any of them is fine. Sorry, go forward like 3. More. So that was good.
Okay.
Go back one.
Yeah, this is the main one.
So, you know, one of the cool things about star schemas is, you know, we call them dimensions. Sometimes we also call them conformed dimensions. We call them that because definition of a store, it's not definition of a store in the context of retail sales fact. It's the context of a store, it's the dimension. This is a store. Store is a store. Have that. So right now we have retail sales fact. That's great. When our next fact comes in, store dimension's already done. Like your first star takes a while.
Yes.
Next star takes less and less and less, and then eventually you get to a point where you're not even doing dimensions anymore.
Yeah, just adding facts. Yep. I should also note an important key to developing these star schemas is you always get your dimensions done first, because what else is it going to foreign key to? You always need your dimensions first, and then you can have your facts so that you can use those foreign keys. I think you're first.
Asked about building quickly. The Kimball method offers something called the bus matrix.
Yeah.
Just quickly identify your grain,
Yeah.
and then you know what you're building. So
That's also in the book.
basically know all your facts, and then what does one row represent? Then you just get your foreign keys to the dimensions. I'll help you go fast.
Yes.
Are you available for consulting, and where do people contact you?
Yeah. I will do my best at being available for consulting if needed, if I have time.
Baby.
Yeah. But you can always reach out on LinkedIn and I can be like, no, I don't have time. So I will absolutely post the slide deck and my LinkedIn on the page. So absolutely connect, keep in contact. And I actually have a couple white papers on my page. I've got my GitHub repo with some of my like educational materials as well as like some projects and stuff. So yeah.